I'd like to give you a very warm welcome from Composites UK. I've been looking forward to this forum, which is a panel discussion. We've got some fantastic people here to talk about composites and the circular economy. My name's Stella Job. I'm the Supply Chain and Environment Manager for Composites UK. I think I've been trying through my work in different ways to help the composites industry to be more sustainable over the last 12 years or so, probably. And I've got to say, I'm not taking credit for it, but I'm really encouraged that a lot of things which were ideas 12 years ago and were niche 6 or 7 years ago are now starting to become mainstream. It's not to say we haven't got a long way to go, but it is really encouraging to see the changes that are happening. And the people who I've asked to sit on the panel today represent some of those changes. And the even more encouraging thing is there are a lot more people I could have asked who would have equally had interesting things to say. So we have here Joe Summers from Airborne, Ben Andrews from ELG Carbon Fibre. This is starting from the outside in. Martin Wright from Polynt Composites, Paul Spencer from Gurit, and Lucy Eggleston from the National Composite Centre. And without further ado, I'm going to ask them to introduce themselves and spend 2 or 3 minutes telling you about their vision for making the composites industry more sustainable. After that, we're going to have an open discussion where we're hoping that all of you are going to take part. There'll be somebody with a microphone who can bring you the microphone and you can ask your question. So please do wait until you've got the microphone. Indicate with your hand if you want to say something or ask a question. So you can ask questions, you can also answer questions and take part, and I'll direct questions to the panel as we go through the discussion. When you're using the microphone, quick tip, please do hold it fairly close to your mouth, because if you hold it down here, it doesn't really work. So keep it up fairly close to your mouth. So if I start with Joe. That's the clicker. Right is forward.
Hello, everybody. So I'm Joe Summers from Airborne. Just a quick introduction to who Airborne are. So we develop automation and digitalization technologies that help make composites lower cost and manufacturable at rate. So I think the first point to make is that composites are inherently sustainable in the first place. They are making planes lighter. They are enabling longer and longer wind turbine blades. And the example on the right is Fleckner rotors on shipping. So before we do anything else, composites are helping create a sustainable world through reducing energy and increasing the durability of structures. How can Industry 4.0 or automation help that? Well, fundamentally, being able to make things cheaper makes them more applicable to a greater number of applications and things. So we're working on trying to produce net shape, reducing waste of materials to increase efficiency. And this diagram is just showing how, from a digital point of view, one of the issues with sustainability might be actually knowing what's in the product. So if we can embed an understanding of the provenance of all of the materials that are in the structure that you're trying to recycle, that will aid developing a recycling strategy. My final slide is this is about how we can, again, use digitalization to inform better design. So the more we can measure and understand about the production of components as they move through the value stream, the better chance we have of taking that knowledge and feeding it back into the design fundamentally to create more efficient designs, better designs, and again, increase the use of composites, which are inherently good.
Thanks, Joe. My name's Ben Andrews from ELG Carbon Fibre. ELG Carbon Fibre are a recycler of carbon fibre from the whole supply chain. So we take waste fibre, we remove any resins, and then we sell those fibres back into industry. My role is kind of helping customers use the materials, the recycled materials, Also speaking to our suppliers who have huge amounts of waste, which we go on to recycle and reclaim the carbon fibre. So for any established material into industry, there is a proven, clear route to recycling. ELG, our parent company, recycles stainless steel. And stainless steel is up at 90% recycling. Steel itself is 90%. Aluminium is 70%. Composites at the moment is less than 1% recycled. So back in 2011, ELG invested in ELG Carbon Fibre, and they're pushing forwards the recycling of composites, specifically carbon fibre, and industrializing that process to make it a sustainable, future-proof material. So from my point of view, the key thing really is standardization. In composites, standardization is a bit of a dirty word. Composites are inherently flexible. You can change resin types, you can change fiber types to get the properties you want. I think for a truly circular, recyclable composites industry, we need to start thinking about standardization, whether that be from fiber selection or even through to the weave format. So getting away from this idea of pretty 2x2 twill to UDs to NCFs, where fibers are inherently more separate, easier to recycle. And on the plastic side, again, standardization. The plastics industry has gone a long way to standardizing the process. You know, there are clear logos, it's clear to recycle plastics. That's not the case in composites yet, so that's a key point. Composites are not a commodity material. Aluminium, stainless, steel, they're all commodity materials. That's a job for accountants, for traders, for sales guys. Recycling composites currently is challenging. It's a technical solution. It's not going to be driven by traders. It's going to be driven by engineers, by chemists. So, I mean, engineers pioneered design for manufacture. OEMs, tier ones, utilized this very quickly because it made them some money. It saved money, improved process efficiencies. But design for disassembly and design for recycling hasn't really taken off as of yet. And that's because the OEMs aren't there to see that profit realized. But I think as composites reach a kind of critical mass, whether that be through legislation or through just the sheer volume, we'll soon see the engineers pushing that forward into recycling. So that's my view.
Lovely, thank you very much, Ben. My name is Martin Wright. I work for Polynt Composites, and we are very unashamedly at the lower tech end of the industry. We're producing polyester resin for glass fiber reinforcement. We're producing vinyl ester and a very small amount of epoxy carbon, prepreg and SMC. One of the things that I think is most important for the composite sector, we're already involved in a large amount of sustainable product. Our customers are already making products for wind energy, for ocean recovery of energy. We're making products for zero-rated housing, and we're heavily involved, although I hate the word, in the light weighting of aerospace and automotive industries. And one thing that I would like to focus on is the importance of the LCA, and I know Lucy is going to talk about this later, but I think as an industry we have allowed our competition in aluminium and steel particularly to hijack the sustainability argument and focus on the recycling factor where they are particularly strong and move people's vision away from the original production and procurement of raw materials where the composite sector has a significant benefit to pay over metals. There are three things that I'd also like to look at which are important today, because although there are a lot of very exciting new developments, and I think the rest of the panel are going to speak about those, there are also products available today which can start to move composites very strongly into the sustainability sector and improve the image and the public vision of what we're doing. The ability to produce polyester resin from recycled PET is well established. It's old technology. It needs some help to bring it through to the market. It needs some commitment from everybody within the supply chain. The use of bio-derived raw materials, again, is standard technology. Certainly my company are producing significant volumes of this product today and selling it into a variety of markets. I know most of our competitors are doing the same, and it's an area where, as an industry, I think we need to start flying the flag a little bit. And the last point was to go back onto the recycling thing, which was one of the key things, particularly for GRP, where we have a low value raw materials going in. We have to organize ourselves together as an industry to find a sustainable and viable recycling route. Otherwise, we are going to fall foul of end-of-life arrangements and create problems for ourselves in the future.
Hello, I'm Paul. I'm from Gurit, and we're a global producer of composite materials. And what this slide shows here is this is the issues that we see the composites industry faces at the moment that we need to overcome in terms of sustainability, in particular circularity. And to develop this, we looked at the UN metrics for sustainability and then extracted from those the ones that I think require a technological solution to advance and resolve. So we start with the design of the composite materials themselves, so making those more sustainable and reducing the reliance on petrochemicals. We then look at how we manufacture those in a sustainable way. So there's often complex supply chains, high energy use and things like that. So reducing our carbon footprint and energy use around waste around producing of those. Then supplying to end users or fabricators. So reducing waste, single-use plastics, consumables such as single-use vacuum bags and processing consumables as well. And then the sustainability aspect around the fabricator themselves. So focusing on making chemical products that are as safe as possible to use, lowering the toxicity and the impact on the fabricators. And then the final one, I think, is the hardest challenge, and the reason we're having this discussion today is to really enable circularity as the end of life within composites, and in particular the challenge around thermoset composites end of life. And I think the obvious thought that we may initially think is around recycling, but I think there's some other avenues to explore as well. In addition to recycling is reduction of waste, reuse or extension of life as well, to minimize the amount that needs to be recycled or disposed of. So those are the challenges that we view are faced. And then this slide shows some of the work that Gurit has done to date to start to progress that. Obviously, there's lots of other things that can be done, but this is where we are so far. So we looked predominantly around resin chemistry and how we would develop a bio-based and more sustainable panel solution. So this combines more sustainable structural core materials, balsa wood, recycled PET, for example, more natural fibers to, in some industries, be able to replace carbon and glass. Lower toxicity chemistry to reduce the environmental impact and impact on users of chemical products, in particular composites. And then the use of high bio-based content materials to reduce our reliance on petrochemical feedstocks as well. Thank you.
Thank you. Hi everyone, my name is Lucy Eggleston. I work at the National Composite Centre as a sustainability research engineer. At the National Composite Centre, we kind of bridge the gap between academia and industry and work with all different sectors developing composite solutions as and when they're needed. A lot of what we're doing at the moment in the sustainability department surrounds end-of-life strategies, alternative feedstocks such as bio-based materials, and also life cycle assessments. But for me personally, I think what the composites industry needs for a transition to a more circular economy is the radical transformation of two distinct but inherently linked systems. The first of which is the more obvious, the materials and products process, and ensuring that all products at the end of their life, they return into a secondary product. The second of which is the supply chain. And I think that in order to enable relifing, recycling, recertification, and secondary applications for primary products, we do need to ensure that the supply chain is fully linked and circular. So at the NCC, what that means for us we work in both of those two systems. We develop products and applications for composite materials that are sustainable and more cohesive with the principles of a circular economy. But we also work with both academia and industry and in a range of different sectors, allowing us the opportunity to also develop the links in the supply chain and make that more circular as well. So at the moment, we are actively involved in a product looking to do exactly this. It's a project that I'm leading, and it is a collaboration between 6 of the 7 high-value manufacturing catapult centres, and it's called Rediscover. It's about composites end of life. The aim of Rediscover is to transform the UK's world-leading end-of-life academic and commercial capabilities into a fully functioning and interconnected supply chain. Over the past 4 months, we've been engaging with loads of different key players from industry to determine what they perceive to be the largest value opportunities. We've then analysed that data and determined a suite of 24 different projects over 4 different streams. And the 4 streams you can see up here on the board right now. And with these 24 projects, we think that if they were successfully addressed at the right scale, we could capitalise on those opportunities and begin to solve the problems faced by composites at end of life. We're now hosting an event at the National Composite Centre on the 12th of November. There is a bit of a dissemination event, some workshopping that will allow us to gain one further iteration of the industrial feedback loop, and also to begin to develop proactive consortia with the drive and ability to capitalise on these opportunities. This has been pretty successful so far, and we've gained some considerable traction, and we're actually looking at over 70 confirmed industrial attendees at that event so far, but we'd really like to get that up further. So if anyone's interested in a workshopping and consortia building event to do with end of life, please do come and let me know at the end.
Thank you very much. Can I have the clicker?
You can have that.
Thanks.
You can have that.
So we're now going to open up for questions. Just a reminder, please do try and use the microphones, both panel and floor, fairly close, sort of about 4 inches from your mouth, works about best. So we've got I put these up as seed questions, really. We don't have to talk about these if you've got other questions which are more relevant. But perhaps just to start with, are there any particular questions directly relating to the things that our speakers have already spoken about that anybody would like to start off with? Yes, so somebody's coming round with a microphone. Yeah, please do.
Thank you.
Thank you.
Why do you think it is that the industry still insists on using single-use plastic to keep atmosphere out of their fibres when they're putting it under vacuum, when the technology exists to reuse a membrane over 1,000 times, and it's available now, and we don't have to fill all that plastic into the environment? What's holding the industry back?
Thank you. That sounds like an excellent Alan Harper question. I should say, actually, when you speak, please could you say who you are and your organisation name when you start? Alan Harper is a legend anyway, so...
Yeah,
Lucy, would you like
so
to
I think I'll take that one. I think a lot of it is primarily driven by cost. That's something that we're seeing a lot in industry at the moment. Cost and ease seem to be one thing that holds back the sustainability of composites, not just in terms of consumables and things, but also in terms of design and product manufacture as well. Anyone else?
Anyone else have a comment on that? Yeah.
The composites market is still niche. Vacuum bags, silicon bags are, in reality, for low volume composites. If we want to make composites grow, we need to move to higher volume manufacturing methods, so closed mold tooling, or even other methods that don't require consumables. Consumables are expensive and need to be eliminated completely, really. I think that is the long-term solution, and that's it, really.
Mm-hmm. Okay. I mean, I guess I could add, it's obviously about what's appropriate for the application, depending on the volume that you're looking at. But that I certainly have come across people where it's really about qualification and conservatism, and they really should be moving to silicon, which I'm sure is the point that you're making. Yeah. Okay, anybody else? No questions related to what the speakers have spoken about? Okay, well, let's start with looking, I think it's helpful if we look at these first 2 questions together. How can Industry 4.0 make composites more sustainable? And can we eliminate waste by moving to net shape manufacturing? Just aware that I think Joe summed it up really nicely, that if we can make things faster and quicker, we can breach new markets. We can get the sustainable benefits of composites into more markets and increase the value of using the composites. So the lightweighting and the durability of composites are having a probably more impact than anything we do in terms of recycling or bio-based materials. So does anybody have any questions or comments about those first two sort of using technology and manufacturing processes to make us more sustainable and how we can do that? I thought you'd all be bursting with questions.
Stella, I would have one comment on net shape manufacturing, particularly from the GRP point of view. I think we have grown up with an industry where the raw materials were incredibly cheap. The highest input into the production was labor, and the cost of disposing of waste was virtually zero. And therefore, we have an industry where people consider it acceptable to produce a significant amount of waste, to not make the investment in tooling and in processing to allow them to produce a net-shaped product. I do see that that environment is changing as the cost of raw materials increases and as the cost of disposing of waste increases. And I think as an industry, we need to highlight the volume of waste which is being generated, because that, I suspect, will be the one factor which will push people within the GRP sector away from making a very large moulding and then trimming it back to size.
Thank you. That's a very good point, Martin. Yeah. One of the points I sometimes lecture to students in universities, and one of the points I make is that there's so many steps in the supply chain, and particularly if you, perhaps carbon fibre prepreg is the worst, where you've got from the manufacturing the fibre to the manufacturing the fabric to the prepreg to the part manufacture. There's waste at every stage of the supply chain, and we're probably throwing away more than half the carbon fibre that's manufactured before it ever gets into a part. When you consider the impact of carbon fibre, which is massive, that is basically carbon crime, to put it mildly. Does anybody have any manufacturing processes in the audience, been involved in any manufacturing processes where you're reducing waste?
Shall I chip in, Stella? I think one of the positive things is that the economics and the sustainability are one and the same. They're inextricably linked. So if you make something cheaper, you're going to try and do that by making it faster, eliminating waste and eliminating processes. So we're inevitably going to help the sustainability thing just by trying to make stuff more economically. And so, I mean, we have a potting machine which reduces potting waste by like 40%. So we sell that on a purely economic business case. It pays back really quickly, and great, we waste less stuff along the way. We have a tape laying machine which would allow you to make net shape preforms. That's good because you don't waste carbon prepreg, and the sustainability is a bonus. We're selling kitting solutions which allow you to increase your nesting complexity, increase yield, and then take care of the complexity through automation and sorting. So I think just driving all of the operational and technological savings to make things cheaper will go at least some way to helping composites. What it doesn't do is address some of these end-of-life issues, which I think remain a fundamental issue to solve for the industry.
Thank you, Joe.
And I think to add as well, from specifically a resin perspective, I think we can look maybe to other industries and perhaps adopt some of their practices. If you take the paint industry, for example, where there's a lot of reuse of unwanted paints or back into the supply chain to create new paints that are reused, potentially the same sort of practices could be investigated within composites. However, that requires a lot of data, which maybe links into the 4.0 type of question, where you need to know what those materials are and you have a more complex supply chain to reintegrate them back in. So you're not necessarily looking at the fabricated final component and how you recycle that, but how you recycle the materials throughout the fabrication process as well. And I think there's many examples in other industries that we could maybe try to look to transfer to, definitely thermosets and composites as well.
Okay. We had a conversation at the Composites 4.0 event, which was quite interesting. One of the thoughts that I'd had, which Joe alluded to earlier, was about tagging of materials, which can be done in a number of different ways. But if you can track, in aerospace, there's quite a lot of that happening, where you can track the material content and the outlife of the pre-preg, for example, and various aspects, the batch numbers of the materials that have gone into it. And there's no reason why that shouldn't contain data which relates to end of life as well, whether that's contained on a tag in the part or perhaps more realistically contained in the cloud, and the tag in the part just links you to a link in the cloud. Yeah, it's one of the things I'd love to see in automotive. Each individual car could be tagged such that it could be robotically dismantled at end of life, and you could get the best value out of every part in the car. So does anybody have any further questions on...
Sorry,
Martin?
I'll just add one to that on tagging of components, because one of the prime problems with the recycling of GRP is the high level of fire retardant product, which ends up in the general waste stream. And because of the halogenated content of that, it creates major problems for recycling. And yet, as an industry, we have no way of identifying or separating that out. So I maybe would throw a question back to the audience. How many of you within your manufacturing process actually would be able to identify a product back several years later and explain to a recycler what had gone into it?
It's probably worth asking, do we have any manufacturers in the audience? How many of you are manufacturers? Not manufacturers, okay. So how many of you are material suppliers? Okay, I wonder who you are. Okay. Yeah. Now I'm trying to remember what the question you asked was. How many of you could identify the materials?
I was asking whether people could identify the materials and track them all the way through the life of the product, because especially when you don't have control. The automotive industry are quite good at this because they've been forced by the end-of-life vehicle designation to be able to say what things are made from and where they should be recycled. But I think the composite sector as a whole is not so good at all.
I think that might kind of go with what Ben was saying earlier about there being so many different variations of composite materials, and there's a lot of IP within materials, and I don't know how hesitant material manufacturers and then producers as well would be to releasing that sort of information. I think it's definitely something that would aid end of life and the circularity of the composites industry as a whole, but I think there's going to be some serious IP issues that we're going to have to overcome to enable that sort of thing to happen. What about Gurit? Is that something that you'd be open to doing? Or?
I mean, I think there's possibly ways of managing that. You don't necessarily have to have it in a completely open platform. You can, as long as you have the data and you have the traceability, you can then share that to allow someone to reuse or recycle as well. So I guess there is some IP around that, but I think it's manageable just with many other things. LCA data as well is a similar example of how you cope with that. So.
Adding to that, Paul, I think the way that we get around it as a recycler is we have large contracts with aerospace people, top secret. The way we get around it is we re-identify the fibres as a new grade, if you like. So we've maintained the properties. We know exactly what the fibre is, but then we've re-identified it into a non-IP sensitive format that people can then use and understand what it is. So almost that is a level of standardisation that has happened, but that needs to carry on through into end of life as well. So there's the tricky bit.
So you're talking about manufacturing waste there?
Manufacturing waste, yeah. Well, also end of life, especially from aerospace. We know what the fibres are. It's obvious. They're qualified materials. We can take that material. We know what it is. We know how to sell it.
Thank you.
I was also just wondering what's actually going to drive all of this, because normally it's some sort of legislation. You've got REACH, for instance, which allows for chemicals for you to determine what raw materials have gone into those. effectively obliges people to register and define those materials. So it wouldn't take much to then extend that by defining upstream of that some methods for how you deal with them downstream. Once it gets to an article and it's cross-linked and cured, everyone says it doesn't really matter what's in it anymore. You can just say it's an article. But maybe we need to go further and say, no, you have to explain what's in the article, and that will allow us to work out how to recycle it.
Yeah.
Following on from that point, and also a point Martin made earlier, as a material supplier in carbon fibre, we have a lot of people in the composite sector coming to us, asking us about glass fibre. Can we recycle glass fibre? And as you alluded to earlier, we don't recycle glass fibre because it's deemed as a low-value material. But worldwide, paper, low properties, it's low value, that is widely recycled. And I think that's on the point of critical mass. So paper is something like 400 million tons a year of paper is produced. Half of that is recycled. Carbon fibre, 100,000 tons a year is produced. 1% is recycled. So as the industry grows, as it becomes more widely adopted, as legislation increases, recycling will just inherently have to happen. So I think it's a bit of a chicken and egg thing. Carbon fibre is being recycled. Glass fibre isn't yet being recycled, but there needs to be a point, and there will be a point where I think it will happen.
With that, though, we often talk about reclamation of the fibres themselves, but 50% by volume is polymeric material, and at current we're burning it off or we're reducing it to a slurry in a chemical, and that inherently means that we're losing 50% by volume of the material. So I think something needs to be done as well to look into how we can reclaim not only the fibres but the matrix. And I don't know what that looks like, and I'd love to hear if anyone has any avenues, but at the moment I think we're focusing so much on the higher value fibre, which does also need to happen, that we're losing sight of the matrix somewhat as well.
I mean, I don't have an answer to that yet, but I think, and going maybe a little bit about Ben's point there as well, there's the discussion of recycling or reuse into lower value items, which is a definite stepping stone towards circularity. But I think then the problem becomes is that you're still requiring resources to replace the material you've taken down a level in terms of value. So you're not having true circularity yet because you can't reproduce or remake the material you've started with. And I think that's a challenge and something that needs to be overcome as well.
So probably worth at this point just briefly outlining what we're doing in Composites UK and our sustainability working group in terms of GRP recycling. We don't have a solution at present. In Germany, GRP is recycled in cement kilns, which the resin is burnt off. The glass fibre becomes a feedstock for the cement clinker because it's an aluminosilicate, which is part of ordinary Portland cement anyway. So the difficulty with the cement kiln route is that you need fairly high volumes to achieve that, and there's quite a lot of testing alongside that. We've tackled that here. It's not economic for us to send stuff to Germany, but we would like to set that up in the UK. So what we've started doing is working with a waste management contractor, and quite a few of our members are now using that waste management contractor to take their waste. So I think he's collecting around 2,000 tonnes a year. We probably need a little bit more before we can get the cement kiln route going, but we're on the right track. We've started discussions with the cement kilns to look at how we can actually do that, and that's an ongoing process. What we would also like to do is, by channeling it through this waste management contractor, it could be diverted to cement kilns, but as we can find recycling routes, the most appropriate waste for those recycling routes, because some sources are easier to recycle than others, could then go to higher value recycling routes. And there's a number of different ways, which I won't go into now, but we have various reports on our website which talk about them. Particularly interesting a technology at Strathclyde University, which I hope the Rediscover and other funding routes might be able to take forward, which may be able to get almost virgin quality glass fibres back out, but it definitely needs to be demonstrated as a business case, and that's a challenge. So we are doing a lot of work in this area, but there's quite a lot more to do. So any questions from the floor before we move on to the next point on the slide? Okay. Does anyone have any questions or comments on biocomposites? Do you think that biocomposites are sustainable? Do you know what biocomposites are? Does anybody have any questions on that? Okay. Would the panel like to make some comments?
Okay, I get to go first. I think this is a really complex area because if you are doing what has happened in the ethanol fuel industry and replacing land which was being used for agriculture for the production of food with the growth of plants purely to fuel a biofeed into power or construction industries, then from a sustainability point of view, that is a pretty weak argument. And I think there is a whole global picture to consider on how are we going to feed everybody in the world and how are we going to provide a long-term sustainable source of the chemicals and the fibers which are needed to continue with this kind of technological development. I would certainly say that if you're looking at biosourced resins, and that would be my, not expertise, but where I would come from, you need to be looking at something which is being produced from the waste products of another industry rather than looking from something which is being grown primarily to produce biochemicals.
I mean, I completely agree with that, and I think a lot of the work we've done at Gurit has been about using bioresins based from waste products of other industries, such as the food industry. It's important you're not diverting or taking that away from other key industries as well. And I think it is important, biocomposites for sustainability. I think it's part of that puzzle or part of that picture. And I think what's also interesting, I think you mentioned that, Stella, is maybe if you looked 5 years ago, the types of biosystems and biocomposites that we have today just wouldn't be possible. And I think it's still very young and needs to mature. And this will drive costs down and bring other developments as well along with that. But I think you need to change how you look and use biocomposites as well. They bring many advantages. They work differently maybe to our traditional materials. And again, in terms of whole circularity, we need to change as an industry maybe how we qualify, legislate and run that industry, and so we can accept different types of materials and work in a slightly different way.
I'm going to slightly disagree with that one, I'm afraid. I think to produce a 100% biocomposite, absolutely everything you've said is correct. But I'm a great believer in the incremental approach to these things. And what you can do is take what is being used, certainly within the GRP sector at the moment, and replace perhaps 20 to 25% of the resin feedstock with bio-derived material. And no, that doesn't answer the total problem. But if you look at European markets, something in the region of 600,000 tons of polyester resin per year, if we were to convert 25% of that to bio-derived, that would make a significant difference. And technically, that could happen tomorrow.
Thank you, Martin. So in January this year, we did a sort of workshop with the Cambridge Institute for Manufacturing to develop a vision and roadmap for sustainable composites. And we used 2040 as a kind of point to look forward to. What can we achieve by 2040? One of the biggest things that came out of that event for me was thinking that 2040 is all very well, but we actually need to be thinking about 2140 and 3040. And when we're thinking in that context, we actually are going to have to go bio-derived, because whether we think it's good or bad to use fossil fuels, there won't be any left. So we're going to have to get everything from bio-derived sources ultimately. So even if it's a small proportion, I think that's a very important step on the line. If we can do 100%, that's even better.
Sorry, yeah,
Thank you.
I thought I'd better make a comment. Somebody's got to undo it. I was just going to comment on what you said, Martin, about incremental progress to 20 and 25%. Doesn't that then add further complexity to what you're left with to try and recycle at the end? Are you not just adding more to the mix?
I would say not at the lower levels, because what you're doing is taking defined chemical products like, for example, propylene glycol, which would currently be derived from a fossil fuel source, and you are replacing that with propylene glycol, which is derived from a biosource. So you're not making a change to the finished resin. It's actually absolutely the same. You're simply finding another route to procure the raw materials that you need.
Just note from other industries that there's been this problem with recycled polyester getting into the recycling chain in that way. So perhaps it's not applicable in the resins stage.
I think the problems of recycling a bio-derived thermoset, in the terms that I'm talking about thermosets with a 20% bio-derived percentage, the problems of recycling are exactly the same. It's exactly the same thermoset.
Lucy, would you like to comment on that from the point of view of the difference between drop-in chemical replacements and alternatives?
So I believe what Martin was referring to are the ones that we call bioplastics traditionally. So they are chemically identical, and therefore their applications and how you deal with them at end of life are exactly the same as well. There are other forms of bio-based polymers that aren't chemically identical, such as polylactic acids, amongst others. And I guess then, yes, you would have new, potentially slightly different challenges. But I think the way that the polymers are formed themselves, they're all going to have similar sorts of challenges, but maybe there's different processing temperatures or different chemicals that are needed to be used. So I guess if you are diversifying further the range of polymers that are used in the composites industry, potentially you are causing an issue there. But if by using bio-based polymers you're sequestering carbon, there's a bit of a toss-up as to whether or not it's worth it, and you can only know that through proper life cycle assessments, including of the end-of-life solutions.
And so far, would you like,
Yeah,
Malcolm,
thanks,
please.
Stella. It's Malcolm Forsyth, formerly of Scott Bard, now independent consultant. Do we need biocomposites? Absolutely, because, in my view, because we can't go on using fossil fuel indefinitely. So to close the loop, we need them. Are they the only solution? No. Are they sustainable? It depends. So it's not a straightforward question to answer, but they have to be part of the answer. I don't think it's realistic that we'll be able to create a fully circular economy using recycled composites as a completely closed loop. There will have to be some feed-in of new material, and therefore biocomposites are likely to be a part of the long-term solution. But they do come with many questions. The point about LCA is very important, because I think unless you're using waste or marginal land, then you get into a very difficult discussion about whether it's better to be making fibres and materials from bio-based sources or making food. So it has to, I think, be differentiated from the food argument quite carefully. So I'd say, yes, we need them. Are they sustainable? You need to be really careful about how you measure it, but they are definitely part of the solution.
And I'd like to add to that, we're talking primarily about the polymers here, but there are also the fibres to consider as well. And we've spoken about the food industry, but there are also other industries that do require those resources as well. So, for example, if you take flax, which is commonly talked about in the automotive industry as a natural alternative to glass, the fashion industry are seeing a massive surge in use of linen, which is the same as the flax plant, which has driven up the cost of flax considerably and therefore is reducing its applicability within industries such as the automotive industry. So I think there really does, as is the nature of a circular economy, need to be a full supply chain, cross-sectoral view on this.
Thank you. Just very briefly comment that I was going to make before about the end of life of the biosourced chemicals. Most of the solutions we have at the moment actually do combust the resin part. And as Lucy said, ideally we would recover materials from that. But when you think of a wider circularity, if you're combusting it, it's better if it's first generation bio-derived rather than fossil-based. And ultimately that will go into the very widest circular loop and come back into the plant system. So I think that that's a valid route. But there are many, many different things. I think if we have about another 5 minutes of discussion, where is it realistic to use recycled material in composites? Perhaps to kick this off, Ben, would you like to talk about the development of the capability for using recycled carbon fibre, because that's seen a massive change in the last few years, I think. Isn't that right?
Sure, yeah. So I'll give an example, shall I, of a route to using recycled fibre in composites. So we're working very closely with ProDrive. ProDrive are a UK Tier 1 supplier for automotive. They use a lot of virgin materials. They are now heavily involved in what they call their P to T, which is primary to tertiary. So the initial use of composites will still be virgin materials, will not be recycled. But the second step will then be using recycled materials in, granted, a down step in mechanical properties, but still using the materials in composites. And then the third use of that recycled material would be, again, a down step into things like chopped fibre for compounding and coatings and areas where the fibre is still doing something. But at that third step, there can be another level of recycling where it goes into a similar material. So I think at the moment, recycling of the material back to its original properties is really very challenging, but there is an established route now for downgrading those fibres into secondary and tertiary structures in materials. So it is happening, and people are using recycled materials in composites now.
Lucy.
Yeah, but there are, so alongside that, traditionally when you're reclaiming the fibres, there is a bit of a reduction in the properties of the fibres due to the heat used. And predominantly they are often then in shorter formats, but there are advances going on at the universities of Bristol and also the University of Nottingham, amongst others. Those are the two predominant ones in the UK that are using fibre realignment processes as well. And they do see some really, really promising results from that, sort of getting up to sort of 90-95% of the mechanical properties of continuous fibres from short, aligned, discontinuous fibres. So these are predominantly academic at the moment, but I think as we see these advance up the TRL scale and get implemented in actual industry, then perhaps instead of needing to downcycle, we'll be able to maintain the value of the fibres and maintain those primary applications.
Yes.
Another point I would like to make on this, and obviously we're all coming from a scientific background, and it's important that we don't try to greenwash things. However, we also need to look at the wider environment that we're working in and the current public perception of things like plastics as a whole. And unfortunately to the general public, they are not going to differentiate between a Sainsbury's carrier bag and an epoxy carbon component, because to them it's plastic. If you just glance to your right and look at that tub of PET bottles there, and that is one of my competitors, by the way, that's actually quite a good image for our industry, because that very plainly says to the public, this is an industry which is looking at recycling something which is a problem, and those bottles it is possible to convert into a usable polyester resin today.
Thank you. Yes. Is there a microphone down here? Thank you.
It's quite interesting. I was at the Dornbirn Fibres conference last month, and there was a company called Indorama. They do a lot of recycled PET, particularly, and the point they were making was recycled PET bottles is just going to be a no-no in 5 years, because it's all going to be reclaimed by the bottle recyclers. There just won't be that raw material available at all. So their idea is that they're coming from the clothing side, but their idea is they've got to be recycling what they're producing. So for them, the solution's got to come from the clothing, not from outside that industry, if you see what I mean.
I think that's a really good point, but I also go back to the incremental view on things. If there is something that we can do today and it has a beneficial effect for us, then perhaps we should be doing that as part of the ladder that we're climbing to the future that Lucy's talking about, where things are more long-term sustainable.
Do any of the panel have any comments on where using recycled materials or bio-based materials actually add value, have properties that you don't see in the normal materials that we use?
Yeah, definitely. So there are a number of different bioplastics that do have inherent properties. So, for example, biopolyurethane has inherent fire-resistant properties, which makes it ideal for use in transport applications where fire risks are heavy, such as train doors, use on the underground and things like that as well. Ben actually told me one previously when I first started in the composites industry, when we were talking about recycled carbon fibre, about the uses of ELG's recycled non-woven mat. And I mean, I'm sure you'll be able to tell it better than I can, but to do with the advantages as a result of the loftiness of the mat and it being able to absorb slight deviations in geometry without having to tailor a layup. So that is, again, in itself an inherent advantage of recyclate that you don't get from a virgin fibre.
Thanks for stealing my point, Lucy. Appreciate that. So, carbon SMCs are virgin fibres. They take long, beautiful virgin fibres and they chop them to very short lengths. So these are virgin fibres that are being chopped. Why use a virgin material when you can use a chopped recycled material, and you'll still get the same properties, the same inherent flow characteristics with short fibres that you would get with the virgin material. So, I mean, we talk about chopping the fibres being a negative thing and taking the length down as a bad thing for mechanical properties, but people do it with virgin material to get process benefits, process characteristics that are beneficial for composites. So, Lucy's point, but a bit more. Yeah.
Just a quick additional benefit to add, and this is a today commercial benefit rather than a technical one, but if a customer of mine is quoting for any public works in Holland, so if they're cladding a public building, if they're putting up a bridge over a canal, if they're putting sound barriers on the motorway, they have to put together a tender to go to the local authority, and it's a points-based tender, and part of that is based on how much of the material do you use is recyclable. So today that doesn't happen in the UK, but I suspect it will do in the near future. You are in a situation where, as a manufacturer of finished parts, you can gain a commercial advantage by using a percentage of recycled products. So I think that's important because it's a factor which will affect people's decisions today.
And maybe to add from a bio resins perspective again, I think there are a lot of benefits that you get from those with the technology we're working on. We've seen a lot of benefits in terms of flexibility, hydrophobicity, so resistance to water and other things like that. So there are benefits that can be capitalized on. And to reiterate, I think my earlier point about maybe challenging how we think about how we might use or utilize those benefits is very important, rather than just looking for materials that can directly replace non-sustainable or lower sustainability materials. And I agree with you, we need a step change. We can do something now as well, but I think it's more of that change of culture to think about how could we use these maybe in a slightly different way and not just look for a direct substitution that will allow us to really develop that technology and progress long term as well.
Thank you. We need to draw the discussion to a close there. I'd like to just briefly point out some of the companies which are members of Composites UK. Composites UK, by the way, has a membership of about 380 organisations, of which 111 are actually exhibiting at the show today, which is fantastic. It's been growing, and it's really exciting seeing the growth in the industry. And it's really exciting seeing sustainability and an honest, not greenwash approach to sustainability as something which is becoming mainstream in the industry. I'm going to point out a few companies. Composites Evolution has flax material. They've also used some bioresins, and they're somewhere on this side. C-Sense is just over there somewhere. They're also using hemp and a bio-based resin, polyfluoroalkyl alcohol. Matrix Composites supply Sycamine green epoxy, which is an epoxy resin which has been around for a long time with a high bio content, and they have various grades of that. ELG's stand is somewhere around over there, is that right? Yeah, you can see the recycled carbon fibre, or speak to Ben. And there's a piece from ProDrive on their stand which looks very impressive. SHD Composites, I'm not sure where their stand is. Is it somewhere down that end? Yeah. They have also been using the polyfluorophorol alcohol, which is 100% bio-based resin from agricultural waste, and they have pre-pregs for rail interiors and for battery boxes because it's very, very fire retardant. And Gurit, where's Gurit's stand? Just speak to Paul. Yeah, so there's quite a few. I probably haven't mentioned all of the ones, but there's quite a number of companies who have interesting sustainable. I should mention Gazashim actually, who supply Polynt's resins, which is just there. Actually, you can see Group Gazashim and the National Composite Centre over there doing all sorts of work and particularly developing life cycle assessment capability, which I am really encouraged by because I think we should be seeing that as inherent in every project and development of every part to understand the life cycle impact of our parts. As a final comment, if you're interested in this area, we do have some good information on our web pages, on our environmental pages there. We've got the report from the Vision and Roadmap for Sustainable Composites. We have a report on recycling processes. We have a much more practical study which we did on FRP circular economy, looking particularly at the GRP from last summer, 2018. And there's a what can I do with my waste page, which gives you the best that we know so far, and tell us if you know anything else, of how to recycle or find better routes for your waste. Just highlight again what Lucy mentioned about the Rediscover meeting on the 12th of November at the National Composites Centre. If you need information for that, please let me know. And if you'd like to know anything about Composites UK or our sustainability subgroup, then please talk to myself or Sue Halliwell, who's standing at the back, or come and visit us on K20. Thank you very much to the panel for really interesting comments there. I very much appreciate you coming along, and thank you very much to the audience. Thank you.